Let me welcome all of you to the 13th lecture of Drilling and Blasting Technology course. In this class, we will continue our last lecture where we are discussing drilling pattern. So, we will continue the drilling pattern, but let us retrospect what we have carried out in the last class. In previous lecture, we got to know about the underground drift and tunnel drilling. In fact, how the underground drilling is little bit different from the surface drilling, that also we have discussed in the last class. So, in underground drilling we need to create one additional free face first before we excavate the main rock. So, basically all this drilling pattern which we are discussing is only for that area where the additional free surface has to be created. So, these different patterns are basically designed to create another new free face for carrying out the blasting of for the remaining rock mass. So, we have discussed about the underground blast phase, heading rounds, those different terminology has been discussed in the last class, and in last class we have already discussed wedge cut and pyramid cut. So, wedge cut basically the cut where the wedge has to be formed first for creating an initiation of a new free surface area, then that has to be widened. So, that complete wedge was discussed in the wedge cut pattern. Pyramid cut is basically a double wedge cut where both the horizontal and vertical wedges are created to carry out the new surface area. So, basically we have discussed that one. Let us all again look what was our objective for these lectures. Our objective was to understand the perspective of the drilling in underground drift and tunnels with particular reference to the different cuts. So, the various cuts patterns essential for the subsurface excavation blasting are being discussed in this lecture. So, basically our objective is to understand this cut from these lectures, and so far we have covered already up to pyramid cut. But before starting this main lecture, let us observe two videos. One basically showing us this is the manual drilling. Say most of the times you will find out that in underground the sufficient room space is not there, that is why heavy machines are not allowed to be used, or there is no scope of using heavy machines. So, most of the time drilling etc. are being carried out manually. So, this is one jackhammer drilling, manual jackhammer drilling is being carried out to take the load of the machine. Basically this air leg is being used. So, what is happened, this basically creates a little bit problematic situation where the drilling control of drilling length, control of drilling direction is very problematic, as the manually it has to be carried out, often 2 to 3 persons are being engaged for carrying out drilling. So, the giving proper direction is very problematic in case of manual drilling. However, if you look into the second video where mechanized drilling is being carried out, you will find out the accuracy of the drilling angle, operational excellence, accuracy on the drilling length, all these are consistency in the feeding, in the feed pressure, and achieving the constant penetration rate. All these are possible to achieve if we are having mechanized drilling system. In fact, nowadays modern underground drill machines are available where computerized drilling is carried out, automated drilling is carried out with multiple boom rigs. So, multiple rigs are available. In fact, tunneling etc. where 100 square meter blasting has to be carried out, phases are available, blasting has to be carried out. 8 boom jumbos are also available to carry out drilling and blasting there. So, you can see this is the 2 boom jumbo. In this 2 boom jumbo there are basically 2 drilling rigs. You can see this is one drilling rig, another drilling rig is in the site. So, simultaneously 2 holes can be drilled, and as it is mechanically operated, drilling length may be more. As the machine is very computerized and hydraulically controlled, the angle can be monitored by the operator, proper angle can be given. Suppose in last class we have discussed OH, if the 60° OH angle is required, that 60° OH angle can be achieved if it is carried out using this type of computerized machine. But while it was carried out by the manually, that person may not properly has the knowledge about the 60°, he may come out with a 45° or maybe 70° angle instead of 60°. So, the total blast performance may be affected because of the poor drilling. So, with the invent of this drilling machines, underground drilling became easier, but till date the problem is that these machines required large dimension openings. So, at least 4 meter by 4 meter or 4 meter by 5 meter room space is required for operating of these machines. So, that is the essential requirement of these machines that has to be followed while drilling has to be carried out using these machines. So, as per our knowledge, we have understood that presently the mechanical drilling is possible to carry out in the underground mines with the invent of the new modern drilling machines. So, that is benefit. We can think of drilling a number of holes, we can think of drilling 100 holes in a face, which is not possible for the manual drilling condition. So, let us continue with the drilling pattern. Last class we have stopped in the pyramid cut, which was basically the double wedge cut. Wedges are given in the vertically and horizontally. In today's class, let us start with the drag cut. Drag cut is basically a half wedge cut. So, we have seen the double wedge cut, pyramid cut, but drag cut is basically a half wedge cut where the angle is given vertically. So, you can see the first drill hole, you can see the first drill hole which is drilled is angling towards the downward, and this is the angle, first wedge angle given. So, that means in pyramid cut we have noticed this one, this was the pyramid cut, okay. This was the wedge cut, horizontal wedge. In pyramid cut there was horizontal wedge as well as the vertical wedge. So, this is horizontal wedge, this is vertical wedge, and if you are looking at this, you remove this part. Let us remove this part first. So, you see this part, this part is this one, this is the hole. So, this is the first hole has to be created. So, this is basically the half wedge where the wedge is vertical wedge. So, basically in other word you can say drag cut is a half wedge cut where the wedge is vertically formed. So, basically in drag cut the first hole is created here. So, this is the first cut, then the cuts are spreaded with these holes. So, finally, this is the position where the new free surface is created. So, in drag cut it is a half wedge cut where vertical wedge holes are drilled and a new free surface has to be created here. So, this is a special type of wedge cut you can say, and drag cut is basically practiced in a case where the soft rocks are available. Drag cut is particularly suitable in small sectional drifts, where a pull of up to 1 meter is useful. More number of short holes are required in this case compared to other pattern in the cross sectional area, and this is useful for the soft rock condition. In fact, you will not observe the practice of drag cut in any hard rock tunnels or in most of the hard rock excavations like metalliferous mines excavation. Sometimes drag cuts are practiced in coal excavation because this is very soft in nature, and that is why drag cut is practiced in those cases as the coal is very soft and the number of rows required in the drag cut is less. So, that is why as it is half wedge cut, the number of delay requirement is also less. So, using that is why the drag cut may be used in case of coal excavation in the underground. Similarly, another half wedge cut is possible where the half wedge is formed in the horizontal wedge, and that cut is called fan cut. So, basically in fan cut, this is the horizontal wedge, these are the wedge spreader. So, if you cut it from the middle, then erase it, erase the rest part. Erase the rest part, you can see this will look similar to this, where this is the first cut angle, then these are the cut spreaders, and gradually it is coming till this, where the new free surface is created. New free surface is created. So, basically this is fan cut. You can consider another half wedge cut, where the horizontal wedge holes are drilled. So, basically fan cut is another half wedge cut where the horizontal holes are drilled. So, basically if you rotate fan cut in 90-degree angle, you will achieve a drag cut, or if you rotate the drag cut in 90-degree angle, you will get a fan cut. So, basically fan cut and drag cut, these two are basically half wedge cut, but only these are perpendicular to each other. So, basically drag is basically the vertical holes, vertical half wedge holes. So, as it looks like dragging the material, as we drag the material like that way, so the formation is, that is why it is called drag cut. Fan cut, it is horizontally. So, if someone use some paper to give air to himself, the way he waves that one, it is similar to that, as this is moving like this way, this is moving like this way, like giving some air to himself. So, that is why it is called fan cut. So, basically fan cut and drag cut both are half wedge cut, and that is why their applicability is more or less similar. Again the fan cut is another half wedge cut. It is applicable mainly where only one machine is employed for narrow drive. That means the small opening soft formation, number of delay requirement is less, and also small advance is targeted. So, in those cases fan cut and drag cut both can be used. So, basically the applicability of this fan cut and drag cut is more or less similar, where you can use fan cut, the same place you can use the drag cut also, but often fan cut results little bit better over the drag cut, because the confinement of the charges are more or less not against the gravity. In case of drag cut it is against the gravity, but in fan cut it is not against the gravity, that is why their performance is little bit better over drag cut. So, basically these are more or less same, but useful for only for the soft rock formation. Now, let us see the burn cut. So far whatever cut we have discussed, wedge cut, pyramid cut, drag cut and fan cut, all are basically the different formation of wedge cut only, and as we have discussed during the wedge cut, the main drawback of the wedge cut is that the drilling length is basically governed by the dimension of the area, dimension of the cross sectional area, otherwise these wedges cannot be formed. So, main portion of the cross sectional area is basically taken by the formation of wedge, that is why these drilling lengths are, or the advance lengths are basically restricted. However, in burn cut this problem can be overcome. What is carried out in the burn cut? A centrally large dia hole is created, which act as a free face for the adjacent holes. So, the basics of burn cut is that all the holes, if you look into the side view, all the holes are horizontal. If you look the plan view, all the holes are parallel. So, basically parallel horizontal holes are drilled in the burn cut, there is no angle drilling. So, basically the key of this is that if you redraw this one, this portion, only this portion we try to redraw, then you will find out there is a empty hole. This is the empty hole, large dia empty hole, and very adjacent to this, hole, there is a small dia hole which is filled with explosive. So, this large dia hole which is kept empty act as the free face, this act as the this face act as the free surface for this explosive. So, this explosive observe one free surface at this position, one free surface at this position, and that is why it can act like a similar manner which is observed in the surface drilling and blasting. So, this is basically essential in burn cut to keep one empty large dia hole which can act as a free surface for its adjacent loaded or charged hole, and that is why the drilling length, the length of drilling does not depend on the face dimension, like wedge cut. So, this is the benefit of using the burn cut. In fact, theoretically burn cut can be designed up to infinite drilling length, but that can be carried out, that may be supplemented with that infinite diameter of empty hole also. So, that is the essential requirement. That means, the drilling length can be designed suitably with suitable design to the empty dia hole. Let us observe the basic of this burn cut in this video. So, in this video there is a little bit modification. Let us see here what is carried out. A central charged hole is placed, which is surrounded by 4 empty holes. That means, this central portion rock you may consider is surrounded by a empty hole, which can act as a free face for that. So, this is the little bit modification carried out what we have discussed in the last slide. So, you can see the first hole is charged, but the empty holes are remained uncharged. This is practically how it is being carried out. You can see this is called pipe charge or gudit charge. No, sorry, this is basically cartridge charge. Say the first hole is blasted, you can see this is the explosive. So, the moment explosive is exploded, first the central portion of the rock, that is dispersed, fragmented, because the empty holes are basically acting as the free face to the first hole. So, let us observe what is there in the burn cut. In the burn cut, a series of parallel holes are drilled closely spaced at right angle to the face. Some of the holes left uncharged to give relief to the heavy explosive in the charged holes. So, basically that uncharged holes act as the free face to the first few charged holes. Then the uncharged holes are often of large diameter adjacent to the charged hole. Since all holes are at right angles, hole placement, alignment are easier than the other types of cut, and it is very suitable for very hard rock condition also. So, basically if you again look into this, the basic idea of the burn cut is first to create a very large dia empty hole, then a charged hole has to be placed adjacent to the empty hole, then you blast that one, so that a new surface area is created like this. Then another charged hole has to be blasted, considering this is the empty hole which will act as the free surface for that hole. So, the new free surface will be created like this. Then the next charge hole has to be placed here. This free area now act as the free surface for that. So, the new free area will be created like this. Then the another one will be created like this. So, simultaneously the free surfaces will be increased, maybe up to a particular cut area, then the rest holes will operate as the stopping holes. So, that is the basic principle of the burn cut, and that is why this burn cut is very popular and very commonly used, especially in the civil tunneling, drifting, where the large perimeters has to be blasted and the faster completion of the project is very essential. In fact, we will learn during our blast design part, we will learn more about the burn cut in that section, but in this class let us stop for the burn cut up to this. But there are two more cut. Coromat cut is basically a double spiral burn cut. If you look into this into the detail, there are two overlapping empty holes. This is one hole, this is another hole, and if you look into this one is little bit closer to this one. So, basically the free surfaces are being created like this, and this one is little bit closer to this. So, the free surfaces are created and by this way the cut area has been created. So, basically this is a double spiral burn cut is basically considered as the Coromant cut, but for the little bit complexity in its design, because of the complexity of its design, Coromant cut is not that much popular. Mostly burn cut is being followed, but Coromant cut is also often practiced in the actual practical field, but their use is very limited. Most of the time we use the burn cut. So, basically Coromant cut drilling is easy. Drilling can be done with handheld equipment. It is principally a double spiral cut, and 2 large dia empty holes has to be drilled in the center, so that sufficient empty space has to be provided for the charged holes. Ring drilling is not basically a cut drilling, but ring drilling is often practiced in the stoping of the mines, especially sublevel stoping, in the VCR method also. In those cases also ring hole drilling, and blasting gallery method also ring hole drilling is carried out. Basically, if you look into the ring hole drilling, the principle is like this. If this is the drift which is supplemented by another drift in the below ground, below level, and this complete portion of rock, has to be blasted together, then ring drilling is practiced. So, what is carried out in ring drilling? This acts as the free face for the ring drill holes, and the holes are drilled in all the direction. So, suppose if you look into this from this direction, this is the opening, then the drilling has to be carried out like this manner. That means, if this is the deposit, this is this level, this is this level, this is the lower level, then sorry, let me redraw it. So, this is that earlier level, and this is the lower level. So, this level is this one, this level is this one. Then the drilling has to be carried out in a ring manner, in all the direction, so that this complete area, this complete rock volume has to be fragmented and deposited in this area. So, this complete portion of rock will be fragmented and will be deposited as a fragment in this position, and the loading machine can take out this material. So, ring drilling is a special type of drilling carried out in the underground, but it is not a cut drilling. This ring drilling is carried out as the excavation drilling, where the already existing free face. So, this free face is already available in the front direction. In that case, ring drilling is basically practiced. So, one free face is at this area side, another free face is at this side. So, all the holes are basically having the free faces. but the production rate which is achieved by the ring drilling is very high. So, basically this is the designing of the ring drilling. TS is the shortest stemming, TM is the intermediate stemming, TL is the longest stemming. These are the design conditions. We will discuss all these things in the blasting part, but blast design part. And this is how each slices are excavated by the ring drilling. Each slices are excavated. This is one slide excavated by one ring drilling. This is another slide excavated by another ring drilling. This is the third slice. So, this is slice 1, slice 2, slice 3. So, these are the different slices excavated in the ring drilling. So, let us stop our drilling pattern in this lecture. We will discuss, we will continue our drilling technology in the next class also. Thank you.